Every time you turn on your phone or flip a light switch, your devices are running on a hidden physical process. The modern world relies entirely on the movement of particles so small they are completely invisible to the naked eye. This diagram illustrates an atom. Those tiny dots orbiting the central nucleus are electrons. They are subatomic particles that serve as the primary carriers of negative charge. The physics governing these particles is straightforward. Identical charges repel each other, while opposite charges attract. Electricity is simply the controlled movement of these charged electrons. By forcing these invisible particles to stream in a specific direction, we generate the energy required to power our entire world. When talking about current, we measure the actual volume of electrons flowing through a conductor in a unit called amperes, or amps. If those electrons sit inside a wire without moving, the current is exactly zero, regardless of how many are packed in. To force those static electrons into motion, you need pressure. That electrical push is called voltage, measured in volts. Just like a high-pressure tank aggressively pushes water through a pipe, voltage forces electrons to move through a circuit. Think of current as the flow and voltage as the cause. You can have high voltage waiting at an outlet even when nothing is plugged in, but you will never get current to flow without voltage doing the pushing. As electrons are pushed through a material, they bump into atoms. That physical restriction to their flow is called resistance, and it is measured in ohms. It is easy to assume that a thicker wire would have more electrical resistance because there is more physical material. Actually, the opposite is true. If you compare a wide water hose to a narrow one, the wide hose passes water much more easily. A thicker wire gives the electrons a wider path, resulting in less resistance. This formula represents Ohm's law. It shows the mathematical relationship between our three properties, stating that voltage equals current multiplied by resistance, or V equals I times R. Look at this circuit diagram and calculate the current. When we rearrange to solve for I, we divide 12 volts by 6 ohms, leaving exactly 2 amps. Altering any one of these three variables forces a mathematical change in the others. Ohm's law is the essential tool that allows us to predict how a circuit will behave, ensuring we can design safe systems and prevent electrical overloads. This page illustrates an array of everyday appliances, showing how electrical energy is converted into practical outputs like heat, light, and sound. The actual energy consumed or converted every second is called power. It is measured in watts, and you calculate it by multiplying voltage by current. Looking closely at the glowing internal elements of this vintage space heater, you can see power in action. Devices designed specifically to generate heat require the highest amounts of electrical power to operate. The entire system follows a clear progression. Electrons carry the charge. Voltage provides the push. Current is the resulting flow. Resistance restricts that flow. And power is the final practical output. This microscopic chain of events provides the framework for all electrical work. By mastering these basic rules, the invisible danger of electricity becomes a predictable, manageable force you can confidently use to build real circuits.